Welcome to this explainer. If you just glance at a globe, the defining feature of our home is undeniably blue, right? We live on a water world. But honestly, from a planetary science perspective, that is an incredible paradox. Earth was born in immense violence and heat. It was in a state that really should have vaporized any liquid long before it could settle. So how on earth did we end up with this beautiful, life-giving blue marble? Well, today we're going to crack open one of the absolute greatest mysteries in geology and astronomy.
Take a look around you. So where did all of Earth's water come from? It's a brilliant question, isn't it? Literally every drop of rain, every cup of coffee you drink, and the vast oceans covering our world, they all have an origin story stretching back 4.5 billion years. And it's a wild story, involving cosmic collisions, icy space invaders, and massive underground magma oceans.
Section 1. The molten early Earth. Let's step all the way back to the very beginning of our timeline, into a chapter of our planet's history aptly named the Hadean Eon. When Earth first formed, it was just an absolute hellscape. It was blazing hot, completely dry, and constantly getting blasted by intense solar radiation. And to make matters worse, any initial surface water would have been completely obliterated by the moon-forming impact. That's when a Mars-sized object named Theia smashed right into the early Earth, creating the superheated rock vapor atmosphere and melting the crust. It was completely inhospitable. There was no atmosphere to hold water in, meaning any moisture would have simply boiled off into the freezing vacuum of space. Unlike Mars, which eventually just froze over, or Venus, which suffered a runaway greenhouse effect that boiled all its water away. Earth's early conditions were uniquely hostile, yet somehow primed from massive transformation.
Now, it's really easy to be fooled by the sheer scale of the illusion our oceans create. Water covers about 71% of Earth's surface area. But if you take the entire mass of the Earth into account right down to the heavy iron core, water makes up only 0.023% of the planet's total mass. 0.023%? Our mighty oceans are, in reality, just a microscopic wet coating on the surface of a giant rock. And actually, because the true mass of our water is relatively tiny, it makes it highly plausible that this water could have been delivered by objects from deep space, long after the planet cooled down.
Which brings us to Section 2, comets versus asteroids. So, if the water came from space, who exactly delivered it? Well, we have two main extraplanetary suspects. First up, comets. These are the icy relics from the very far edges of the solar system, out in places like the Oort cloud. They're basically giant, dirty snowballs, shielded from the sun's heat, which makes them perfect cosmic cargo ships for ice. Our second suspect? Asteroids. These are rocky pieces of rubble residing much closer to home, primarily hanging out between Mars and Jupiter. And while they might look totally dry on the outside, many of them actually have liquid water literally jumbled up inside their mineral structures. For decades, scientists fiercely debated which of these cosmic vehicles delivered our oceans.
Section 3. The deuterium DNA test.
To solve this, scientists had to become, essentially, cosmic detectives. They needed a way to genetically match the water in our oceans to the water floating out in space. Okay, so let's dive into this concept real quick, because it is the absolute key to the whole mystery. Not all water is exactly the same. Standard hydrogen has just one proton, but there's a heavier isotope of hydrogen called deuterium, and it has an extra neutron in its nucleus. When deuterium bonds with oxygen, it creates what we call heavy water. The ratio of normal hydrogen to deuterium, the D/H ratio, was permanently locked in during the very birth of the solar system. By comparing the D/H ratio of Earth's oceans to bodies in space, we can trace exactly where our water came from. It's a literal chemical fingerprint.
When the European Space Agency sent the Rosetta probe to intimately study Comet 67P, they found that its D/H ratio was way too high, about twice that of Earth's oceans actually. In fact, current models predict that less than 10% of Earth's water could have possibly come from comets. But look at the asteroids. When the Japanese Space Agency sampled the asteroid Ryugu, the D/H ratio was a near-perfect match to Earth's seawater.
So the crucial takeaway here is that a specific class of ancient space rock, called carbonaceous chondrite meteorites from the outer asteroid belt, were likely the primary delivery system for our water. They crashed into the Earth over millions of years, bringing their locked-in moisture with them. Case closed, right? Well, not quite. While the water matches, scientists noticed that the trace amounts of noble gases, stuff like argon and xenon, found in these asteroids do not perfectly match the noble gases found here on Earth. There is a glaring gap in the story.
Which leads us to a massive plot twist. What if we didn't just import our water? What if our planet was brewing it all along?
Section 4. Water from within Earth.
This brings us to a radical and honestly fascinating idea, the endogenous theory. This suggests Earth acted as its own water factory. The clues for this were actually found in the deep mantle basalts of Baffin Island in Canada. Scientists discovered that these volcanic rocks contain water with a deuterium to hydrogen ratio that is incredibly low, much lower than our surface oceans. This highly negative D/H ratio indicates that this specific water wasn't delivered by asteroids at all. It was inherited directly from the original dust and gas cloud, the protosolar nebula that birthed the sun itself. It has been trapped deep inside the Earth since the planet's formation.
Based on some truly groundbreaking findings from 2025, researchers proved that during Earth's early days, it was covered in a magma ocean at staggering ambient temperatures of around 4,000 Kelvin. I mean, that is hot enough to melt iron. Under these extreme conditions, hydrogen gas from the solar nebula dissolved directly into the molten rock. This hydrogen then chemically reacted with the iron oxide in the magma. This specific geological alchemy stripped the oxygen from the iron and bound it to the hydrogen, generating absolutely massive amounts of water right here on the planet.
We tend to think of the surface oceans as the main reservoir of water on Earth, but recent estimates suggest that Earth is hiding almost 8 entire oceans' worth of water deep inside its interior. And astonishingly, about 60% of that total hydrogen inventory is dissolved straight into the planet's metallic core. The vast majority of our planet's water has just been trapped underground this whole time.
Section 5. Cooling and Ocean Formation.
Okay, so we have water delivered by asteroids and water manufactured in deep magma oceans. But how did it finally get to the surface to create the blue marble we know today? Well, it's a 3-step, beautifully cinematic process over millions of years. First, as the Earth's interior churned, volcanoes and tectonic activity continuously outgassed this trapped water vapor into the early atmosphere. Second, thanks to that thick blanket of gases, the Earth's surface eventually cooled below the boiling point of water. And finally, the skies opened up. The water vapor condensed, leading to a torrential, millennia-long rainstorm that literally filled the ocean basins. This monumental event didn't just create liquid oceans, it kick-started the global water cycle of evaporation and precipitation that continues to sustain our planet today.
Section 6. Extraterrestrial Life Implications. Now, let's zoom out for a second. What does this complicated, messy origin story mean for the rest of the universe? Well, if Earth didn't solely rely on the lucky, random impacts of icy asteroids to get its oceans, if it actually manufactured a huge portion of its water from a primeval magma ocean, that changes everything. It means that countless other rocky exoplanets orbiting distant stars might also be born water-rich. They might be brewing their own oceans right now. And since liquid water is the absolute fundamental prerequisite for biology as we know it, planets sitting in the right habitable zone might be incredibly common.
So, to summarize our investigation, the final verdict on the origin of Earth's water isn't just one single event. It is a wonderfully complex cocktail. We inherited a massive base of water synthesized in a primordial magma ocean, we had a heavy delivery from carbonaceous asteroids over millions of years, and we likely received a tiny splash of exotic ice from comets passing by. The water you drink is a blend of the solar system's entire history.
Which leaves us with this really powerful concluding thought. Every drop of water holds within it one of the greatest mysteries of our planet. The next time you look at the ocean, or even just turn on your tap, remember that you're interacting with ancient cosmic artifacts. Some of it was forged in a 4,000-degree magma ocean, and some of it traveled millions of miles through the freezing void of space just to get here. It really makes you wonder, what other secrets is our blue planet hiding?